Hi everyone. Welcome to this next talk on PDG. Today, what we're going to do is we're going to talk a little bit about how to get at various hooks in the system so you can customize PDG to kind of get it to do a little bit more what you want, more custom functionality. Okay, so customization of technology like PDG is, of course, key for many facilities. In the past, we already talked about how to create custom nodes, right? And so in this talk, we're not going to rehash that territory here. But instead, what we'll talk about is with custom schedulers and this thing called the data layer. So with custom schedulers, we already ship a bunch out of the box. There's local scheduler that allows us to take advantage of all the cores. We have our in-house HQ, which is free. And then there are the commercial ones, Tractor and Deadline. We have default bindings for all of these. But you may not be aware of how to maybe, to where to go to customize some of that functionality if you are using our HQ binding or Tractor or Deadline binding or even the local scheduler binding. How do you add a little bit of extra functionality to that to make it do a little more what you want, right? And, also this topic of making a custom scheduler is a very, very important one. So today I'll cover at least the basics of what's involved there. How to make a custom scheduler is a more involved topic that probably deserves its own talk. But today at least I'll give you an overview of what's involved there. So you can go and make some customizations, and as an exercise we'll make it a little dummy scheduler as an example. The next bit, this data layer bit, is a really powerful bit of architecture we put in place for Houdini 18. What it allows you to do is basically it separates the UI of PDG out from the backend compute of PDG. And by doing so, this allows us to basically attach a UI to any remote instance of PDG. So that means you can submit a PDG job to the farm and go home, shut down your Houdini stuff or pilot PDG stuff, go home, and if you're wondering how that thing is doing, you can just start up another session of PDG and attach to the headless one and see its state. And in fact, it doesn't even have to be a session of PDG that's doing that. You could even potentially start up a web browser pointed to that remote instance and you'd be able to see its state. Okay, so that's really, really powerful, obviously. But beyond that, there's more there. This same system allows you to peer into the current state of PDG through what we call snapshots. A snapshot is essentially a dictionary of properties that you can just iterate through to see what the current state is of practically everything from nodes to work items. And then, even more importantly, this allows you to hook into PDG's event system with updates. You can subscribe to certain things and be notified through callbacks when those things happen. So, for example, when a work item changes state, when a node is added or deleted, or even a topnet is added or deleted. So this allows you to hook into those events and smartly do stuff based on those events. Okay, so let's start with schedulers. A little bit of a recap. What are schedulers supposed to do? So PDG itself is not a scheduler, right? It just talks about things that knows how to do things, which are the processors, and the work items, which are actual invocations of those processors. So each work item is actually something to do. So at any point in time, some subset of the work items in the system are actually ready to be executed. And the schedulers are supposed to take those work items that are ready to be executed, and it'll run them somewhere. Okay, somewhere could be locally on the current machine. It could be on the farm. It could be on the cloud. So it really doesn't, PDG doesn't care where somewhere is. So once the scheduler takes the work items and gets them done somewhere, it is supposed to inform PDG of its status. What happened to that? Did that succeed? Did that fail? What's going on there, right? And ultimately, supposing it succeeded or failed, it'll inform PDG where to find the logs, right? And if that was done using an actual compute farm, such as HQ or Tractor or Deadline, there may be a farm status page where you might want to kind of be able to click on that and see the logs of execution, right? The status and so on. You might want to be able to attach files and attributes as results to the work items, as a result of the computation, attach more attribute or files to the work item itself. The work item, in order to execute, might have some dependent files that has to get to the right spot so that it will actually succeed. All the dependencies are there, right? And so it's responsible for doing that as well, making sure all the files that a particular work item would depend on has to get copied to the right spot. The user might be able to pause or cancel or resume the cook, and it has to handle that. A lot of these schedulers have properties, such as the number of cores and slots or memory or software licenses that is required to do a job. And one might want to actually expose these properties then onto the processors such that it can be customized on a per work item basis, right? And then there's some potential hooks into the start and finish of cook, or the initialization of the scheduler itself to bind it to the right underlying scheduler. Yeah, so that's about a high-level overview of the responsibilities of the scheduler. Okay, so with that, let's start delving into stuff. Okay, first things first, we want to know sort of where are all the important files? Where do you even find this stuff? There are two places to look. So firstly, in the Houdini install, Houdini Python 27 libs/PDG folder, where you're going to find a lot of the base classes. Okay, and then the other place to look is in the install location, Houdini PDG types. Okay, so if we kind of take a look on my system, so this is the Houdini PDG folder. You can see here's the types. And in here, you're going to see a whole bunch of stuff. Here's the scheduler, right? In the scheduler folder, you'll find the actual implementation of the local, Tractor, and Deadline schedulers, right? In the types, actually, there's a whole bunch of other stuff as well. Might as well mention them. All the stuff that you get when you tab. A lot of those actual implementations of those classes and nodes are here, right? So here are the partitioners. Here are some like the HDA processor in Houdini, the top fetch, all of that stuff is here. And for utility, the FFmpeg, the CSV file, shotgun implementation, all of this stuff is here. So you can customize the implementation of many of the stuff we ship by modifying the Python script here. Be careful with that, of course. So outside of the types, there's also the examples folder, which is, we ship a number of example files. These are also a really good reference. So without further ado, let's take a look at the other major location, which is Python 27 libs, right? And here you'll see a PDG folder. By the way, you also notice a PDGD thing. We'll talk about that later. That's the data layer stuff, okay? So here you see a lot of the base classes. So here the scheduler.py, for example, is the base class, Python base class for all schedulers. What else would I say? Yeah, so for PDGD, if we look here as well, so Houdini whatever, in the Houdini folder, there's PDG, this folder we just looked at, but there's also, again, PDGD. And we'll be looking at this a little bit later as well. Okay, so here are the basically the places you would look for files. Okay, so now that we know where to find the files, let's take a deeper look at what's involved in terms of writing a new scheduler. So the PyScheduler base class is the main one sort of to subclass from. But in addition to this thing, you're actually going to need usually a couple of helper classes to also subclass from. There's this one, the event dispatch mixin, which you can find here, and its job is to get these callback from these callback events that you're getting from the jobs to actually dispatch them to PDG. There is the callback server mixin, which itself subclasses from the event dispatch mixin, right? You can find it here, and what it does is basically provides a callback server that's implemented in XML RPC that jobs can call to update their status, right? So if you think about it, we'll have all these things sort of running out of process, and that could be on the local machine, or that could even just be on the farm. And when they're done, they have to inform PDG somehow of their status. And the way they do it is by calling back to this callback server through XML RPC to tell PDG what is actually going on, right? And once it gets that message, it will then use the event dispatch that it inherits from to actually dispatch these events to PDG. Now, the reason these are not just a single class is that the event dispatch mixin is always local. The callback server mixin can sometimes be remote, right? As in the case of the farm, right? So these two are separated in functionality. Now, so usually just the use of these two things is enough. But there are cases where we get into more complicated situations. After the launch of 17.5, we found out that there are certain issues with certain farms. Okay, and the issue is that we're running into firewall issues and DNS issues with not being able to resolve like machine names. And the MQ relay was introduced as an alternative to the callback server mixin, so that we can sidestep some of these firewall and DNS issues. The idea is that we have the MQ relay, which can basically live on the side of the farm, and every farm job talks to the MQ relay, and MQ relay establishes this persistent two-way socket connection back to PDG, thereby sidestepping the firewall and DNS issues. And so you would use the MQ relay as an alternative to the callback server mixin in cases where you're dealing with this type of issue, okay, the firewall DNS issue. Okay, so these are basically the high level classes you would need to sort of implement your own scheduler. Let's take a quick look at the PyScheduler. So you can find that under Houdini, whatever, the Houdini folder, Python 27libs, and then PDG, and scheduler.py. Okay. Now, if I pull up this file, you can see PyScheduler here. This is the base class. You're going to see a bunch of stuff in here that you don't need to really concern yourself with. This stuff, for example. There are helper methods in here that you may or may not care about. There's stuff in here, though, that is you're not going to find in the docs. And I'll point them out. That may be important to you. So that's this stuff here. So this work item succeeded, work item canceled, failed. So the event dispatch mixin expect these classes, these functions to be on a scheduler, and the PyScheduler implements these methods here as default behavior. Okay, so you can see what happens by default if a work item succeeded, calls this thing. And so it goes for all these work item blah things, all the way down to about sort of here, right? And so if you want some custom behavior for what happens when certain things happen to work items, this is the methods. These are the methods you would override to get some different behavior. Like I said, you might notice some functionality like transfer file already has an implementation, so you can rely on that one if by default. And if that's not good enough, you can override that. Here's stuff like getting the status and log. That's for a particular work item to click on that. If you want to return those, that's where you do that. There's also stuff in here that you don't need to really concern yourself with. That's stuff like this. Okay, these methods are considered more advanced and more internal, so you don't have to worry about those. So there's some stuff here I wanted to point out because that's not in the docs, namely some of what I mentioned before, and there's some helper methods that you may find useful. But it's only one place where you look. Okay, the other place where you look to get a better sense is in the docs. Okay, so if you pull up this page, you'll be able to see the methods we inherit from the scheduler base class. And there's some stuff in here that's not in the PyScheduler, such as onStart, onStop, onStartCook, onStopCook. And the reason for this is that these methods are not actually required. And so the PyScheduler doesn't provide a default implementation for them. Okay, so this is another point of reference. And finally, a third point of reference is in Houdini itself. If I put down a topnet and put down a Python scheduler, this is a node that we provided to make it easy for you to start customizing your own scheduler. So you'll see in here there are all kinds of tabs and on whatever callbacks already there for you to fill out the body of, right? So this is actually, sort of the first place to start doing stuff, and we're actually going to do something with this node a little bit later in our exercise. Okay, so yeah, that's sort of the rough overview. Okay, now that we've looked at that, let's do a little exercise where we will write ourselves a dummy scheduler. We will log the start of cook with some modification to onStart cook. And additionally, we'll make it so that only even indexed work items will succeed, and we'll just fail the others. And we'll attach some, quote-unquote result file and result attribute to the work items after they are done. Yeah, and so let's get to that. So I'm gonna pull up my session of Houdini here, and I'm gonna put down a topnet. Dive in. By default, as usual, you notice the local scheduler, but we're not gonna use that, so let's just get rid of it. Instead, we'll put down a Python scheduler. And as mentioned before, this is a node that we've created to make writing custom schedulers a little bit easier. You would use this thing to iterate until you get most of the functionality or almost all the functionality. And at that point, you would save this Python script to the appropriate location, and I'll show you, where once you've done that, that's finalized. You can then sort of go through the process of making it an HDA so that you can start changing the interface and putting a better skin on it. First thing first, which I'll probably just kind of go through all these tabs with you and talk about all these different callbacks and what they do. Okay, so the scheduling, the on-schedule callback is obviously the most important one. This is when you get the work items and you actually are going to do something about it. We'll come back to this a little bit later. Okay, the schedule static is interesting. It's more advanced. Basically, the idea here is that you would walk the entire task graph, just get the entirety of the description, and then you would go and translate that into a job specification and just send that very, very complicated job specification to the scheduler. The submit as job basically takes the top or PDG network and runs that thing as a job on the farm itself. Okay, so the actual running of PDG is completely handed off to the farm. Here, basically what you want to do is concoct some kind of Python string to run Python with the name of the current hip file, whatever that may be, and point it to the PDG or top network to actually run, right? So both of these are, we can consider them advanced topics. Okay. Next, in the initialization tab, the start and stop, these are one-time initialization. Okay, so these get called when you put down the node for the first time, you get the start and stop. These are only called once per lifetime of the scheduler node. The start cook and stop cook gets called every time you start and stop the cook. Okay. The shared server idea here is basically is for things like the command chain stuff, right? You might want to start up a session of Maya or a session of Houdini, and at the end you might want to tear that down. So this is when you actually handle that logic. The transfer file we actually saw a little bit earlier. The default implementation, it just calls into that one. The logging is interesting. Here is when you would append a little bit of a particular log to a work item, so that when the user brings up the task info panel, there would be a link there where they can click to get the log and also the status URI, the farm status URI, right? So that's kind of the high-level walkthrough of that. But let's come back to our intended task here, which is to log the start of the cook with onStartCook, and then make certain things succeed and fail others. So let's get to that. Okay. So I guess in order to make things to log the onStartCook, we simply would modify this one, the onStartCook callback here, and we would write something like print, cook has started, right? And let's see if that worked. Let's put down a generic generator here, and when I cook this thing, hopefully that would work. Oh, but before I even do that, we've changed the scheduler, but what we need to do is we need to change the default scheduler to actually point to that, right? So we're under object here, so we should point that to the Python scheduler. So now we're good. So hopefully now when I execute this thing, we should get that. And if I bring up the Houdini console, there it is. Okay, so cook has started. So yay, we have that. So now let's try to make it cook not 1, but 10 items. And let's try to make the even or odd ones fail, okay? So for that, we would go to the modify the onSchedule callback. Now let's take a closer look at this thing. This method here, create job dir and serialize work items. So the work item data, all the attributes on it, has to be serialized into a file of some sort, so that that file can be transported to the right spot onto the farm. And this method basically handles all of that logic for you. It makes sure that the appropriate directory is created, wherever that may be. And it serializes the work item and copies that there. And we'll take a look at what's showing on disk a little bit later to see what this call actually has done. This next one, expand command tokens, what that does is, all the underscore PDG stuff, PDG dir, etc., all of those actually get expanded into real paths at this point. These job environment variables are some of the stuff that is basically some of the environment variables that are that's pretty much expected in every cook to be present. So we set those here. And in this case, you can see just all it does is call a sub-process to run this thing, spawn a process, right, and cook it out of process. And then depending on the return code, we return succeed or failed. So in our case here, what we want to do is we want to modify this a little bit, right? So we want to say, instead of relying on return code, we would say, if work item dot index mod 2 is 0, then maybe we'll succeed. Otherwise, we will fail. Okay, so let's just do that. And let's see how that works. Save the file, and dirty, and cook, and everything actually succeeded, so that didn't actually work. Now, why is that? It turns out that for things like generic generator, where there is no command, there's nothing to do, it actually takes a shortcut code path where it doesn't even actually try to schedule these things. So in order to actually force it to do something, we can put in an actual commanding here, or we can turn on this delay thing, which will force it to actually get scheduled. So if I dirty this thing and cook it again, you'll see it's actually spinning. So that's a good sign. And let's see what happens. It's going, it's still going. Oh, there we go, Christmas lights. Okay, so this did precisely what we wanted. So some of these succeeded and half of these failed, right? Next thing we'll want to do is we'll want to sort of, what did we want to do here? Let's check back here. Right, attach some dummy result file and result attribute to these work items. So we can do that by simply adding some more stuff here. We can say work item dot add result file, I think. We can always sort of check on that with the online docs. So if I look at PDG work item, there is add result data. Okay, so that's the one. Result, tag, and checksum. Okay, so that's the wrong thing. It's not result file. Add result data. And I said no. Foo.txt. The tag would be file/text. And the checksum is 0. And we can just do that. And to add an attribute, we can say work item.data, which is a, so you can check on the docs here. Work item, there is a data property, so which is work item data. And we can say set string, for example, okay? Work item.data.set string. And this is probably the first one is the name of the attribute. So foo string, bar text, and the index is 0. So let's do that. So if I dirty and cook this again, hopefully we get the right result. Okay, if I middle mouse on that, there we go. Foo.txt, which is file text, and foo string with bar text. Okay, maybe one last thing. If we kind of go back here and go to the logging bit, let's attach a little bit of text to the status URI, so we have actually something to click. I just literally copied this bit here and put it here. And let's see what happens. Dirty and cook. So hopefully this time, in addition to what we saw before, we're going to be able to see this particular link show up. And there it is, right? So at this point, our little exercise is complete. We'll save our Python script, okay? So click this button, and we'll call this, random scheduler. Random Python scheduler. Create a label, random, that, and let's change that as well. Random Python scheduler, and then you notice it goes to the PDG types folder. So let's accept that. And if I now middle mouse click, let's do that here. There should be a random Python scheduler, which is that. Okay, which we now can then open up the type properties and then start modifying its interface to make it a little more friendly, right? But let's take a look on disk as well to see what's going on there. Let's say, oh, actually, you know what? This is, while we're here, we might as well point this out. So this is all the runs we just had. If you're clicking here, notice all these JSON files. These were what has been serialized, right? So randomly take one of these here. You can see the serialization that's taking place, right? And takes the work item data, serializes it, and it copies to the right location. In this case, it's on my local system. It's under the PDG temp folder here, but it could also, that method also makes sure it gets to the right spot on the farm if that's what the scheduler is doing, right? Yeah, and the other bit I wanted to show, I guess, is here. And if we look here in PDG types, here is the random Python scheduler that we just created. If we take a look at the text in there, you can see it subclasses from both callback server mixin and PyScheduler as we discussed. And some of the methods here, you can see the onSchedule has our custom code in it, right? And at this point, I would refer you to take a look at the local scheduler and tractor and deadline scheduler to see, the more detailed implementations of what's involved there. Okay. Actually, before we leave this topic behind, let's push our example a little bit further. Let's add a setting on the scheduler to control whether we fail the even or the odd items. And then let's take this setting and let's expose it on a per processor basis so that it can override the default setting on the scheduler. Okay. And the basic steps to being able to do this are the following. We would add a property to the node template with a naming convention, and there is a naming convention here to make this work. We would check for the property with evaluate int override to make it take effect. And at that point, we would add this file, this topscheduler.user.ds file to the Houdini path so that it shows up in the Houdini properties, type properties, so that would allow us to be able to customize that setting on a per processor basis. And then we would drag that thing over through the parameter interface so that we have that setting exposed. And we'll show you how this works. Okay, I've got Houdini open again from about where we left off. Remember, we have this Python scheduler. We added a bunch of code here. And then we sort of went up and clicked the save to Python script. Now that it's sort of quote unquote finalized, we won't be using this one. We'll be using instead the one that we plunked down, which is that we saved, right? Which we called random Python scheduler. We need to go up a level, and we need to now point this thing to our new node, which at this point I'm just going to run once to make sure it still does what we think it does, which should be just fail every other work item, right? Just going to give it a second here. Hopefully, there we go. Get the Christmas lights. Okay, so at this point, we'll start customizing the functionality based on what is on disk. So if I kind of browse to the folder where it's at, you can see I'm editing this file that we saved out, which is in the Houdini PDG types directory, right? And what we'll want to do is we don't want to be using this name because it's way too long. We'll call this random scheduler, okay? And then here, we'll also call this random scheduler, so it's consistent. And then you notice the parameters stuff is completely empty right now. Now for inspiration, I'm going to go look at the implementation of the local scheduler, which is here. And you'll see that its parameter array is not empty at all. And in fact, I'm going to just kind of find one that looks sort of like what we want to do and just copy and paste that. So let's do that. Notice though, all this stuff with the name is prefixed with local underscore something, okay? And that is because these are the local scheduler, and that naming convention, as you'll see, is important. Okay, so I'm going to go back here and paste this in, just making sure that we don't introduce any tabs versus space problems in Python. So for our comment, we'll say, you know, fail either even or odd work items, right? So the name, instead of local underscore single, this has to be prefixed with the template name of our scheduler. So it has, instead of local underscore, it has to be random scheduler underscore, and we'll call this fail even, okay? Label is fail even. Integer, this tag has to be there, it must be there for the scheduler stuff, and we'll even give it a default value of 1, okay? And again, making sure there are no space versus tab issues. Okay, let's save the file. And then next, we'll have to make sure this actually takes effect, right? And again, we'll look to the local scheduler for inspiration. If we now search for this single flag, let's see where it gets used. Right here, okay? So notice that it's using this evaluate int override as opposed to the normal evaluate int. And that is because we have two versions of this parameter here. There's one sort of the default on the scheduler itself, and then there's another one on per processor setting, which we can override the default one on the scheduler. And so because of these two potentially conflicting settings, we'll want to use this one instead that takes that override into account. Okay. Now to sort of prevent you watching me typing a lot, I'm just going to sort of copy and paste the right version of the code. All right, so let's see what it does. So again, we can't use the evaluate int as you might expect. Instead, we'll have to use this thing. This part here has to be the template name, and this is the actual parameter name, okay? And you can see here, basically, if it's failing the even stuff, well, we would fail the even, otherwise we would fail the odd ones, okay? And so at this point, I'm gonna save this file, and we have to go and restart Houdini to make this take effect. So I'm gonna do that. Okay, so I've got my Houdini restarted and loaded back the file we were just working on. But you'll notice first thing is that the new parameter we added is actually not here. And the reason is that when we saved the file, we saved in the old definition, which didn't have that, right? So we have to get rid of this and just put down a new version of the node. And there you'll see it is now there, right? So now let's give it a quick test to make sure this actually works. So I'm gonna cook this. Since fail even is set to 1, we would expect all the the even ones to fail, right? So there we go. 0, 2, 4 are failing. That's all good. But if we set it to 0 and dirty and cook again, we would expect instead all the odd ones to fail, right? Cool, this is all working, right? So at this point, we would want to take this setting here and expose it on a per processor setting so that we can overwrite that on a per processor basis, right? Now to do that, we'll need to do a little more customization, okay? Let's go back to our notepad here. And once again, we're going to look to the local scheduler for some inspiration. So right now I'm mousing over a file called local.ds. If I show where that is, you can see it's here and under the Houdini install Houdini properties top folder, there are these DS files. What these do is make sure these properties for the scheduler get exposed in the type properties window. Okay, so if I look at the local DS stuff, if I look for that single thing again, actually it's right here at the top here. We should use something like this basically for our own random scheduler, right? And so that's what we're going to do here. We're going to go, what we need to do is basically expose a DS file somewheres on the Houdini path. Okay, and how do we know where the Houdini path is? We can open up a Python shell and say who.Houdini path, run that, and you can see here for me the documents Houdini 18.0 folder is part of the Houdini path. Okay, so I'm at the Houdini 18 folder and I'm gonna place down this top scheduler.user.ds file. It has to be so named, okay? And if we look inside, basically we have exactly that. So notice the naming convention here. It has to be the template name underscore your property name, right? With the parameter tag, this has to be all hard-coded like this, okay? Okay, so with this file, once this is in place, we have to, once again, restart Houdini. And we're going to do that. Save the file first, and then restart Houdini. Okay, so once again, I've got Houdini restarted. And this time, I'm going to go to the parameter interface of this generic generator and edit it. Okay, so I'm just going to bring this down here. Under the Node Properties tab, once we collapsed object properties, you'll notice the settings for all the schedulers. And you notice deadline, HQ, and now that we have the local, and now that we have our DS file there, this allows our random Python processor to show up, okay? And I'm gonna take our fail even setting and drag it over to the schedulers tab. And this exposes it onto the generic generator node. So if I go to scheduler tab, now the fail even tag is there. So notice our default scheduler setting has the fail even set to false, but our per processor setting has it set to true. So hopefully this should actually override the default, and we should have even work items failing here. So let's see that actually working, hopefully. So it should be that the even work items fail. And it does, okay, as we would expect. And if I were to plunk down a new version of this thing, this one we didn't actually expose that setting. So if I were to simply cook this guy, we should have a different pattern. We should be using the scheduler default. Oh, what I should do is actually change the number of work items to 10, and I have to turn on that delay so it actually gets scheduled, right? So dirty and cook. And this time we should have a different fail pattern than what we see here. It should be the odd ones failing. And yep, it does, okay? So that pretty much covers this part of our tutorial. Okay, now that we're done with the basic scheduler bit, we're ready to talk about the data layer. As mentioned before, this is a powerful new architecture introduced in Houdini 18 to decouple PDG UI from PDG's compute. We haven't yet talked about it a lot because it just needs a little more UI UX for mass consumption. And so it's being launched in beta. But if you're watching this video, you're the one who needs to know something like this. Um, so it's ready for advanced users, and basically, like I said, it's powerful in a couple of ways. Not only does it allow attaching a UI, any kind of UI um, to a running PDG, headless PDG instance, but also you can get these things called snapshots to iterate over the current state of PDG through basically a dictionary. And you can get, more importantly, you can get event deltas to get the status updates from PDG. There's a lot you can do with this system. Okay, let's take a look at the high-level overviews of it. So the basic idea of the data layer is that you're able to have these things called visualizers that are able to subscribe to any level of PDG, either at the highest level instance, subscribe to a particular graph, a node, or even a work item. Okay, and the overall system looks something like this. Okay, so we have PDG here, and you'll notice here is that data layer. The visualizer, uses the data layer to visualize the PDG state. So TOPS is a visualizer, an example of a visualizer. It is also a driver. The idea of a driver is something that can modify PDG state. So the TOPS UI is something that is both able to modify the PDG state through being a driver and also being a visualizer of the PDG state. Another example of a visualizer is the task graph table, right? You can peer into the state of PDG, but also, there should be an arrow here that's sort of missing. Because we are now able to change the state of PDG work items through the task graph table. So it's also a driver, right? Other examples of PDG visualizer are things like we can create a state server where we can connect external applications to it and even be able to connect things like a WebSocket to it. You notice there are these things called the backend. There are subscription. Okay, so firstly, there are subscription and subscription options that allow you to express interest in certain things in that's going on in PDG. There's also this idea of a backend. We by default create a lightweight backend that already works, but you can create more interesting backends and more efficient backends, such as Redis, that can optimize certain things. So the creation of backends and stuff like that is way beyond the scope of this talk. There will be further masterclasses to describe how to work with the details of the system. But today we're going to focus on this bit of it, right? How do you create a visual? Well, not even how to create a visualizer. I think that too is pretty advanced. We will use an existing visualizer to peer into the events in PDG, and that already is a very useful functionality that we can definitely leverage. One more bit about data layer. You can see basically what it does is that it allows PDG to be PDG and do its own thing, which is focus on the computation of the graph in the most efficient manner. Anyone who wants to know the state of PDG talks to the data layer, and so that basically offloads that functionality to this bit here. So that this thing can focus on its job, which is to serve out state to as many folks who might express interest in PDG's state, right? So it decouples that functionality. So that's quite a bit of theory. Let's take a look at what this looks like in practice. Okay, so here's a little video that we pre-recorded. This, by the way, is an example we actually ship. Okay, so here I have a PDG instance, and here we have a totally separate running session of PDG. You can see we're cooking a top graph there, and lo and behold, that just showed up in this. Let me just back up a little bit just so you can see it. back up. So yeah, so this is the other running section of PDG, and notice that this little graph just popped up. When we double click on it, we can see that the state of the other session, right? Yeah, like I said, this is something we ship, and you're welcome to take a look at that example. So here I have another example. So here we have a running session of PDG going somewhere, and then here's using a phone. Joab, our developer who implemented all this, he's using his phone to connect to that session of PDG, and you can see all the top or PDG graphs showing up, and then you can even get a sense of the that top graph running on actually his phone. So that's pretty cool. Yeah, so next let's go take a look at this stuff on disk and where we find these examples. Okay, so I have my install of Houdini right in front of me, and you can see here we can find these examples in my Houdini installation folder under Houdini PDGD. The D stands for data layer, and examples. Okay, and there are two of them here. The monitor instance, which is the more advanced of the two, which we could take a look at the end. But let's start with this one. This one is the most useful. Okay, so if we dive in, you'll see that there's a HIP file and then a bunch of Python files. If we open up the HIP file, it looks like this. It explains what's in here. In fact, there are several demos in here. The most basic one actually is this thing called Hello PDGD, right? And what we'll want to do to run it is to source it through an exec file. So let's do that. Let's bring up a Python shell. Make sure that's visible. And what we can do is, whoops, I'm just going to copy this line of code here because I'm lazy. Here we go, import this and run that. Okay, so Control C, Control V in here. And it's not PDGD2 that I want to run, it's just PDGD, okay? So right away, you can see it gives us a list of graphs, okay? And if I go up here, if I put down new top network, you can see that we're getting that echoed, and then put another one down, and that's getting echoed as well, right? And if I delete it, we're back down to this one. So let's take a look at the code to see what's actually happening. So it's this file we're going to be looking at, right? And so here's hello PDGD. So you can see here we're importing this thing called the PDG object, okay? And we're also importing the PDGD module. What we have here, what the PDG object is, which I'll take a quick look at that code in a second, it's an actual visualizer. Okay, we won't get into the details of how to implement such a visualizer. That's beyond the scope of this talk, but we're just going to use it. So here I have a function. All that it does is prints the object and message that was passed to it. And here you can see we're creating an instance of this PDG object with simply the string PDG passed in. Okay, now this is hierarchical. If I want to know about a particular graph under PDG, we'll add a slash, with the graph name. If I want to know a node, it would be another slash with the node name, and then down to the work item, and so forth. Okay, we'll see give some examples of how to do that a little bit later. So all that we're doing is by giving it a top level PDG thing, we're saying we are interested in any context level things for PDG. And so we call this method initially once, right? And then we add a listener to it with with the method name. And that's why every time sort of I added one of those top networks, we got the print is because of this add listener. And this manual call is why we got the initial print from the that says sample visualizer, right? It's this thing here. So that's at the basis level how this could work, and is very, very simple. You'll notice though that if I cook the nodes in here, we're not getting any prints, okay? And that's because we haven't expressed a deeper level of interest. We have only expressed interest at the very top level, right? If I put down on the top network, this does print. So how do we do that? So to do that, let's take a look at the next example, which is PDG-D2. If we go to PDG-D2, let's actually execute it first. So if we just sort of, I already have it actually copied, so I can just paste. So this time we're doing an exec file again, but on PDG-D2. And now if I cook this, now we're getting the updates from nodes and work items in this graph, okay? So let's see what's going on here. If we take a look at the code here, again, we're importing this PDG object from this file, this module, okay? And we're also importing the PDGD module. So, so this time is slightly more complex. Let's see here, where's the main code? I can't scroll down that far. Let me bring that up a little bit. Okay, you can see the first thing we actually do is we create one of these PDG instance things, okay? If we sort of scroll back up and see what that involves, just like before, it's expressing interest at the very top level. It's adding a listener, just like before, and it's manually calling this instance updated method, just like before, okay? The only difference though is that in the instance updated, we start doing further things in here. We start going through all the graphs, right? Removing any that we have that are no longer there, and we add in for any that are that are present that we don't yet have. We create this graph object on it with the graph name. And what this thing does, this graph object, if we go a little bit further, is it starts to express interest again, right? You can see it starts with PDG / and then it appends to it the graph name, right? And then it creates another visualizer with a PDG object with a more detailed path name, which is now PDG / whatever the graph name is, right? And then it adds a listener to that more detailed path, right? And then we also call it once just to get the initial information. But every time now the graph changes, this graph updated method is going to get called. And here is when we start iterating over the nodes and work items in that graph, and that's why we're getting that thing updated every time. You know, now when I cook the graph, right? So following this logic, you can see you can kind of express interest at different levels in the graph, and get all kinds of really interesting updates. Following this logic, we can go even a bit further and run this run tree view example. And if I click on this button here, you'll see that it actually creates a hierarchical view of the current state of PDG with, that's the network, that's this is a node, right? And here are the work items in that node. And here are the properties of the work item in that node, including things like its state, right? One thing about the state, though, you might see these magic numbers. You might not understand exactly sort of what they mean. If I can find that Python shell, right? So for example, you might see that, let's bring back the viewer, that this state here has the number 5. So if I have, I need the PDG module to do this. So if I say PDG, so import PDG, so PDG, and if we say work item type, or work item state rather, and we give it that same magic number, and you'll see that that actually means cooked success, right? So that's how you, for work item states, that's how you would interpret things like that. The other bit to mention is that you'll notice, importantly, these things called the IDs here. The work item has an ID, and in fact, so do the nodes. And some words here, I think it's in the hello PDG, PDGD2 sample, this one here, okay? You'll see some comments as to how to get deeper level subscriptions, okay? You would get deeper level subscriptions by using the graph name and then the node underscore with the node ID, okay? So those node IDs and those work item IDs can be used in this manner to get deeper and deeper levels of subscription. Let me just bring that up a little bit. You're not seeing that. So here's the work item underscore work item ID. You can use that to express interest in that particular work item. Okay. Okay, so that's almost it. Let's finally take a look at that more advanced example. And I'll just roughly describe to you what's involved there. So if I pull up the monitor one and run it, let's see, just cook this guy. Nothing's happening yet, but if I cook this guy as well, things will start happening. So you'll see that a whole bunch of Pythons just popped up. And if I now look back here, all those 4 sessions of Pythons are now reflected in these viewer nodes. If I double click inside them, I can actually see how the internal state of those Python instances. Now, what's happening is that these are special nodes. These things are called, I think, remote graph, I think. Okay, yeah, remote graph nodes. Okay, so if I look at one of these things, if I plunk down one of these things, you can see I can point it to a host and just give it the IP and port, and it will be able to connect to that host and display its state. So that's what these things are. They're connecting to, this is my machine name, and that's the port they're connecting to. So, but what's basically happening in this sample here is that this network here starts a XML RPC server, and it starts to listen for things. And when I run these, this network, these will spin up a bunch of Pythons. And what they will each do is they will call back to the XML RPC server that we started here and register their IP and port, okay? And when this guy gets a callback, it'll stop the cook of the graph and restart it again. And for each IP address that's registered, we create one of these work items. And ultimately, that filters down to creating these viewers, which will create one of these nodes here and put it in the right spot, and onto each node, fill in the IP and port that was registered with it, and push the connect button. So that's basically what's happening in this example. It's a fairly advanced thing. So, we talked about this last year. It's only sort of, there's a lot more details in here that are in the comments, in the code, that you can kind of figure out for yourself. And if not, feel free to ping us, and we'll try to explain it better in future videos and with our responses. Okay, so that's about it for now. And thank you again for listening. And until next time.